So let's say I'm having an array of size, let's say 5 again. Let's say 1, 2, 3, 4 and 5. Okay. So in that case, what we were doing, let's say 1 is present here, 2 is present here, 3 is present here, 4 is being present here, 5 is present here. Okay. In that case, what our DQ operation, DQ function was doing, DQ was just deleting 1 from here. And so what it was doing, it was just shifting all these elements one step backward. Okay. Because of this operation, we are getting big of n time complexity. Big of n time complexity. What we can do instead of this performing these two, we are already having two pointer, let's say front and rear. Well, these are not the pointers, these are the variables. In English grammar, we can say that it is acting like the pointer because it is pointing to some index. But if you say into the C++, it is not a pointer, it's just acting like a pointer. In English grammar, I'm just saying it's pointer. Do not confuse in it that we are using pointer without an asterisk sign. Okay. So already we are having front and rear. So what our front or rear is doing, it is just simply doing, it is just having the value, means it is front is having the index of or front element in that queue, and rear is having the index of the rear element, that is the last value, that is the last index of our queue. Let's say I want to delete this from our queue. So instead of doing all these shifting all these elements backward, what I should do, I should increment my front, and now front should point to this element. Let's say in this case our rear is pointing to this element, not the rear plus 1, not this index plus 1. Let's say we are having two pointers, rear is pointing the last element and front is pointing, instead of this front element, it is pointing to front plus 1 now, because we have already deleted it. Let's say I want to delete one more element. What I'll be doing, I'll delete it from here. Now our f will be pointing to this. F will have the index 2, 0, 1, 2. F will have the index 2 and it will be pointing to this element. Okay. So let's say someone is asked us to enqueue something in our list. So if we enqueue something, let's say I want to add 10 to our queue again. And if I want to add something after 5, if I want to add something at index 5, because it is at index 4, if I want to add something at index 5, we'll get an array out of index, because the size of this array is already 5 and we cannot access the index 5 because it's start from 0 and up to 4 only, it goes up to 4 only. So what we can do here, 10 instead of 10, insert here, insert 10 here. Let me erase all this first elements. Okay, just give me 1 minute. Okay, it is deleted. Okay, leave it. Okay, let's say 1 is being deleted from here and 2 is being deleted from here. I want to add something to our array. The array was something like this. Okay, and r is pointing to this element right now. I want to add 10 into it. So instead of adding here, I should add it here. Okay, now our r will be pointing to this element. So f is currently pointing to this and r is pointing to this element. Let's say one more element I want to add. Let's say I want to add 20 to it. Okay, now instead of rear pointing to this element, rear will be pointing to this element now. Okay, let's remove it. So if I want to add one more element to it, now we cannot add because our queue is already full and there are 5 elements already present. We cannot add anything. So this time, if you want to do this, our the set of means conditions will be different. So what we can say, if rear is equal to f minus 1, because if r comes before f, what it means? It means our q is full, as well as those conditions will already be there. If front is equal to 0 and rear is equal to that size minus 1, that is that in that case the capacity was there, capacity minus 1, in that case also the q will be full, means we cannot add anything. If f is pointing to this first, this zeroth index, and rear is pointing to this size minus 1, let's say 5 minus 1, this is fourth index. If rear is pointing to fourth index and front is pointing to zeroth index, in that case also that q will be full. Okay, is that clear with everyone now? And uh, why we are doing this means that condition will be also be there, and we'll add one more condition to our full function, is full function. If it is full, then this will be then what it means q is already full if this condition satisfied. Or we'll write an or operator, because of if this means if either this condition satisfies, if f is pointing to this and r is pointing to this, either this or either this condition satisfies. Ensure if anyone of from both, if anyone condition satisfies, it means that our queue is already full. Okay, let's say, okay, I'll be using this scheme. Let me remove all these first. Okay, let's try to design our enqueue function for it. Let me write it again. Let's say in this case, in the starting, let's say I'm writing f is equal to minus 1. Our front will be minus 1 and rear will be minus 1. Okay, and if I want to add something to our queue, I'll just check. I'll be checking before adding something. If front is or rear is equal to minus 1, then what we'll do? We'll add. Let's say our queue is empty and front and rear is equal to minus 1. In this case, there is nothing in our queue. If I want to add something, then the 10 will be added here, and the front and the rear element will be the same. Okay. Then f and r will be pointing to 0, means it will be updated to 0. Okay, as well as if I want to add something, add one more element to it, at this time our rear is 0 and it is not minus 1, then it should just increment 1. I should be incrementing 1. 10 is let's say 10 is here, 20 will be present here. Now r will be pointing to this element now, and f will be pointing to this front element only. Okay, let's say I want to I want to add one or two, three or more elements. Let's say 30 I want to add, 40 as well. Okay, let's say 50 as well. Let's say 60 as well. Let's say size of this queue is 6. Okay, what if I want, I just performed a DQ operation. Let's say I performed a DQ operation here. In that case, what, instead of f pointing to this element, which element or f will be pointing now? Now f will be pointing to 20. Okay, it will not point to 10. Let's say I want to add something to our queue again. After 60, we cannot write and means rear plus 1. I should be checking first whether our queue is full or not. If it is not full, it means that this elements, that f is not pointing to this, f is pointing to index 1. So it will, that function full returns, it will return a false value. That means it is not full. In that case, what we'll be doing, I should be writing let's say rear is pointing to this element, I should be writing, let's say r only because we are writing r for rear. Let's say what I should be writing, rear plus 1 modulus capacity. So 1, 2, 3, 4, 5, and 6 size of let's say capacity is 6 because in this case capacity is 6 and this index is 0, 1, 2, 3, 4, 5. This index was 5. Then r was r plus 1, 5 plus 1 percent 6. Jadip is asking, sir, will this full class upload on YouTube? Yes, it will be uploaded on the YouTube, Jadip. Don't worry about that. Okay, let's say in this case r is 5, then 5 plus 1% 6. It means 6% 6. 6 modulo 6 is 0. Then in the rear we'll get 0. Let's say r is equal to r plus 1 modulo 6. Modulo capacity. In this case capacity is 6. So we'll get 0 in the rear. So we just let's say 70 need to be added. So 70 will be added here. Okay. And now our rear will be pointing to this element. In this case, rear is equal to f minus 1, front minus 1. Now our queue is full. Okay. Let's quickly write the code for it so that you can be more comfortable to the. Are you clear with the concept of this code? Means these functions means nq and dq, or do anybody is having any doubt regarding this function? Okay. Let me open one more IDE for it. I'll be writing code for it separately. Just give me 1 minute. Okay. Okay. Let me write the code for it. Nan is saying here it is clear. Okay. Good. That's good. Class. Let's say I'm writing Q again. It's a class. In this case, front and rear will be there. We have already did that. Rear. Let's say capacity is also there. Okay. And pointer of type int will be there, and public. I'm writing it quickly. All this constructor will be public. Let's say Q. Again, I'm giving size to it. We have already discussed, means in the starting it will be -1 and will be -1, or still do anybody is having any doubt, you can ask that in that group chat. Let's say array is equal to int, sorry, new int of size. Okay, capacity will be size. I'll be writing void enq here. Intl. I'm checking if is full, then what it should write? It should write that cout q is full. Okay, and it should return from here only. Okay, we don't need to write else. Let's quickly write the is full function first. What are is full function rule? It will return type of this function will be bool itself. Let's say bool, and what I'm writing here, put the name of a function is full. It will not take any argument. Let's say if what are code, in what cases our function our q will be full. Let's say that first case will be same again. If front is equal to 0 and rear is equal to capacity -1. Is that clear with everyone? I'm writing here. Why I'm writing this? This will be the first case. If front is pointing to our first element, that is 0th index, and rear is pointing to the last element, it means our queue is full. Or the second case could be, I'm writing an OR operator here. The second case could be if rear is equal to front minus 1. In this case also our queue will be full. So I'm writing return true, else return false here. So now our enqueue function will do, if it returns true, it will print queue is full. If it returns false, it will what it will do, the 28 line will be executed. Let's say I'm writing, before doing that I should be checking whether our, let's say instead of front I am writing rear, if rear is equal to -1, in which case rear will be -1. In the very initial case, in that case there will not be any value into our queue. What I should be writing in that case, I should be doing front is equal to 0 and rear should be 0, and at the position rear you should add that value, and before adding that just print and statement that inserting. Or do anybody having any problem with the codes? Means if you are facing any problem, please do ask. Lesson, I'll repeat that, don't worry. If you are facing any issue, please do ask in the group chat. So what I'm doing in this case, in the very initial case, if rear is equal to -1, not clear with the rear is equal to front -1. Okay, Aryan is saying not clear with the rear is equal to -1, front -1. Aryan, please see that in this case, let's say 5 element is being there, and now our F is currently pointing to this. Now let's say front is 3, then 4, then 5, then 10, then 20 is being added, and rear is pointing to this. This is 0 index, this is 1th index, this is 2 index, this is 3 index, this is 4th index. Okay, so if 1 is equal to 2 minus 1, what it means? It means it is already, it is full. Means if rear is equal to f minus 1, it means there is nothing in our, if rear is at the back of front, it means our queue is full. Okay, Aryan is saying it is okay, it means it is clear with you. Okay, let's move to our code again where we were. If rear is equal to -1, then in that case we are doing front is equal to 0, rear is equal to 0, and array of real is equal to value. Okay, as well as if this condition, let's say it should return here, means why I'm returning here, because if we have already added this value, then the function, then the work of this function has completed, and it should return here. Okay, so now what we have did in that case, rear is equal to, if all these are if these two cases are not satisfied, it means that there is something in our queue and we want to add some more elements. Okay, so rear is equal to rear plus 1 modulo capacity. Why I'm writing rear plus 1 modulo capacity? Because let's say 10 is here, rear is pointing to 10 currently, and rear plus 1, that is 0 plus 1, because the index of 10 is 0, 0 plus 1, 1, and 1 modulo, let's say size of this array is 5, 1 modulo 5 is 5. But if this r is pointing to here, r is pointing to here, and it is saying r plus 1 modulo capacity. So r plus 1, let's say r is 4, and 4 plus 1 5, 5 modulo 5 is 0, and r will be pointing to this element. Okay, so let's say rear is equal to rear minus 1, and array rear nan is saying to rotate. What to rotate means, I don't know, nanny. Okay, please elaborate what you want to say. Uh, till that. Okay, you are saying to rotate. Okay, yes, to rotate. We are doing to rotate. Okay, so now if rear is being incremented means, so I'm writing array of that rear, it is equal to value, and before doing that I'm printing a statement inserting that value into a queue. Okay, I hope the enqueue operation is clear. Okay, let's quickly design our function dq. At any point if you face any problem, please do ask, will not pass any argument to it. Let's say if is empty, let's quickly write our code for empty first. Bool is empty, in which case our means our queue will be empty if front, let's say rear or front or rear is equal to -1. In this case our rear should be incremented. We have already incremented rear, Aryan, we have already incremented rear. Rear is equal to rear plus 1 capacity. Let's say rear is having index 0. Now rear is equal to rear plus 1, 0 plus 1 modulo capacity, 0 plus 1 modulo 5. So it will be 1 only. It will be incremented by default. Okay. So if rear is equal to -1, it should return true. Yes, or Q is true, else return false. Okay. And if it is empty, it should print a statement that Q is empty and we cannot delete anything. Q is empty. I should be writing /n and it should return from here on. What will be that case? It means that front is equal to rear. Okay. In that case, what I need to do, I just need to front is equal to -1, because if there is nothing in our queue, I should be having that value in front and rear. It should be -1. Okay, and it should print a message here as well that cout deleting, let's say, that value that is there in our array at the front. It will print a message deleting that element. Okay, now front is equal to -1, rear is equal to -1. If that is not the case, there could be two cases only. Let's say I just need to increment my front. Front should be now front -1. Front is equal to front plus 1, not -1. It should be front plus 1. But in this case, let's say, let me remove all these first. Just wait for a minute. So let's say one array is there, array of size, let's say again 5, 1, 2, 3, 4, and 5. Okay, let's say front is currently pointing to this node and rear is pointing to this. In that case, if I want to delete something, I should be increment my front is equal to front plus 1. But let's say I was keep on increment, means deleting my front, and I have reached here, and I have did means I have means I have added some more elements here. Let's say 10, 20, and 30. Let's say rear is now pointing to this element, and 5 is present here. Let's say now front is here and rear is here. So in that case, if I say front is equal to front plus 1, let's say this is 0, 1, 2, 3, 4, then it will be index 5. But I should not be having index 5 in our front. And the next time if I want to, means if I want to get the value of that front, index front, which will try to check the value at the index 5, that will give us the array out of index bound. So instead of f plus 1, I'll be writing f plus 1 modulo capacity again. F4 plus 1 modulo capacity, 4 plus 1 5 modulo 5, it will come here, it will come 0. The value will be 0. So it will come here. Okay. It will. I hope it is clear why I'm writing front is equal to front plus 1 modulo capacity. Okay. Anushka is saying it is clear. That's good. Okay. Front is equal to front plus 1 modulo capacity. And before doing this, I should be writing that deleting array of, let's say, value front, because we are deleting front. Okay. Let's say I'm changing my line here as well. Okay. New line. Okay. So here it should return, because if I'm not writing a return statement here, we, with this statement, this will be performed. After that, these statements as well will be performed. And we don't want to perform these statements if front is equal to rear. If front is equal to rear, it means there is only one element present in our queue, and these only these four lines should be executed in that case. Okay. Let's quickly write our print function for it. Let's say print as well. I should be checking. There will be two cases. If front, let's say front, because front will be either this side. If front is less than rear, what it means? Let's see. If this is the case, let's say front is here. Front is currently pointing to this node, and rear is this pointing to this node. The values will be between front and rear. If front is less than rear, I should be running a loop from front to rear. But in this case, if front is greater than rear, then I should print and front to capacity and loop front to capacity, and I should be running one more loop from 0 to rear. Okay. Because it will start from here. Let's say front is currently pointing to this node, and rear is pointing to this node. So how our queue should be printing? It should print 4, 5, 10, and 20. Then what I'll be doing? I'll be iterating a loop from front to capacity and from 0 to rear. Is that clear? So if front is less than rear, then I'll be writing only one loop. Let's say for int I is equal to 0, I is less than, I is equal to front, I is less than or equal to rear, I plus plus, and I should be writing cout array of I, and should be writing there. Let's write some statement here. Printing elements of the queue. Okay. If it is not the case, it means it will come into else part. Let's quickly write the else part. If it is not the case, then I should be printing from our value from where int I is equal to front. I should be less than from capacity I plus plus cout array of I. I hope now it is clear what I'm writing here. If it is not clear, please do ask in the chat board. If I from front to capacity, and I should be I is equal to 0 from I should be less than or equal to rear, because at the rear there will be some value. Array I. The else part is clear. If front is less than rear, then these statement will be executed. If it is not less than that, this statement will be executed. Okay. If we have few elements in empty, few elements empty, then it would print random values. in front is less than rear. Ashish is saying if we have few array elements empty, then it would print random values. No, why it will print random values in between them? No, it will not be the case because Ashish, try to understand it here. I hope get it means I'm got what you are trying to say. So you are saying this will not be the case means there will not be any empty value between f and r if f is less than r because let me write it for you because if f is less than r, f is pointing to this node. Let's say f is pointing to this, and you are saying, and the data, let's say some data is being added, and r is being printed, r is here pointing to this node. You are saying that if there is some elements that is blank in this positions, if it is there is no elements present, this will not be the case because we have we are means adding elements one after each, one after each, one after each. In the second case, it could be the case means let's say let's say front comes here. Let's say these two elements is being deleted. These two elements is being deleted, and rear is being added here. One element is being added here, here as well, and here their elements will be there as well. Okay, if rear is being added means rear is currently pointing to this node. If we are trying to add one more element, so instead of this, rear will add one more element here. So yes, in this case, this statement means this index can be blank means there could not be any case. Because of that, we are printing first from this to capacity, and after that we are printing from 0 to rear. Okay, in the first case this will not be the case means there will not be any empty values in between. Okay, Ashish, now I hope it is clear to you now. Okay, if it is not, please do ask it again. Okay, let's quickly write or create an object for our code. Let's say I'm again writing it 5 q dot nq 10 q dot nq 20 q dot nq 30. Let's say I'm trying to print q dot print. Let's print our code. Nan is saying int I is equal to front. Okay, she's giving, so I've not written semicolon here. So I is equal to front while I is not rear, print array of I. Yes, you can do that, Nani. You can use a while loop only instead of this. So array of rear is going to value, I think it was val in this line number 33. We have written value here. Let's see, is there any problem? Okay, 10, 20, 30. Then you can do that means you can use a while loop instead of doing if else condition and writing 3 for loops. But for making it simple, I'm using this means these for loops so that it could be understandable to everyone. Let's say q and q and q and q. Let's say I'm adding 50 as well. Let's see 10, 20, 30, and 40, 40. Okay. Let's say I'm trying to add one more element. Let's see whether what happens. Okay. So it is saying that queue is full and we cannot add more elements to it. Let's try to delete something before adding to it. Let's call our dequeue function here. Let's see whether our dequeue is performing well or not. Deleting 10, inserting 60, 20, 30, 40, 50, 60. I think our function is working fine. Or do you want to test it on any other test case? If you want to do that, you can write it on the group chat. Okay. I hope now it is clear to you all. If you are facing any doubt, please do ask in the group chat. Or I'm assuming that it is clear if you're not asking anything. Okay, can someone quickly tell us what the time complexity of dq, this dq function here? Okay, Nan is, Aryan is saying 1, Nan is saying 1. Yes, it is big of 1. Means I hope you got that means concepts. Okay, okay, that's good. So I'm wrapping up the session for today. I hope it is clear.